Okay, let's unpack this. We live so much of our lives online now, right?
Hmm.
We have profiles, usernames, avatars. But what if you could have a real, verifiable digital identity, something you actually own, not
Yeah.
tied to any single company?
Yeah, something truly self-sovereign.
Exactly. And that's the core idea behind decentralized identifiers, or DIDs. They're a foundational piece for this whole vision.
Precisely. Instead of, relying on Google or Facebook's database to say who you are, DIDs let individuals, organizations, even like IoT devices,
Right.
have identifiers that are globally unique. You can look them up. They're cryptographically verifiable and, crucially, independent of any central authority.
And today, we're diving deep into a specific technical document. Gets right down to the nuts and bolts of one particular way to do this.
Yep.
We're looking at the method specification for Ethereum from the Ontology Developer Center. Specifically, how DIDs can work on Ethereum using the did.etho method.
And this isn't just some high-level overview, right? This is a spec doc. It lays out the precise rules, how you structure did.etho identifiers, how you manage them, how you interact with them on Ethereum.
Okay, so our mission for this deep dive is let's crack open this spec, pull out the important bits, and really understand what did.etho is, how the specific identifiers are fundamentally tied to Ethereum, how they're managed on the ledger, and, well, why understanding all this plumbing matters for the future of digital identity.
Yeah, why it's key for verifiable identity in this decentralized world we keep talking about.
Exactly. We're basically looking at the blueprint for one way to build this stuff on a major blockchain.
That's it.
All right. So diving into the spec, it kicks off by grounding us. What are DIDs in this specific context? We hear the term a lot, but how does this document define them?
Well, at the most basic level, it says what we just discussed, identifiers for verifiable self-sovereign digital identity. But what's important here, I think, is that the spec doesn't exist in a vacuum. It explicitly states it conforms to requirements from the W3C Credentials Community Group.
Ah, and that W3C conformance, that's pretty significant, right?
It is, yeah.
It means did.etho isn't just like its own standalone thing. It's designed to play nice with other systems, other identity methods that follow those W3C standards.
Exactly. Interoperability. It's part of that bigger picture, that ecosystem.
Yeah.
And this document, it focuses on just one specific way to implement DDIs, which it names using the official name string ETHO.
ETHO. Got it. So if I actually see one of these DIDs out in the world, what does it look like?
The spec is super clear on this. It must start with the prefix did.etho.
Did.etho.
And it emphasizes that prefix must be lowercase. No exceptions.
Okay, did.etho, all lowercase.
Yeah.
What comes after that second colon then? Is there a specific format or is it just anything?
Oh, no, it's very specific. There's a defined structure for what they call the namespace specific identifier, the NSI.
Right, the NSI.
For did.etho, the NSI follows this format definition. It's in ABNF. Etho-specific ETH string equals 4040H xdig.
Okay, hold on. 4040 HEXDIG. 40 hexadecimal digits. That sounds, hang on, that sounds exactly like an Ethereum address, doesn't it? Just without the 0x.
You got it. That's the absolute core insight here. This whole specification, it deliberately ties the DID directly to an Ethereum address. That 4040 HEXDIG is the Ethereum address, just like you said, without the 0x prefix. The example they give makes it obvious. did.etho.1F4B9D871 Fed2DCB 2670-880-237F7253BB 5766D.
Let me see. Yeah, did.etho.prefix, and then, yep, 40 hex character. It maps directly.
Exactly. It's the prefix plus the address.
Okay, that's a really crucial connection. The identifier is derived from the address. So given that structure, where do these DIDs actually live, and how are they managed?
Well, because they're derived from Ethereum addresses, they fundamentally reside on the Ethereum blockchain. That's their home base.
Makes sense.
And the associated DTD documents, the data that describes how to authenticate, how to interact with the identity, those are managed using a specific smart contract. The document just calls it the registry.
Okay, so the Ethereum blockchain is the base layer, the decentralized infrastructure. And this specific smart contract, the registry, is like the dedicated phone book or management system for the did.etho documents on that chain.
That's a great way to put it, yeah. It's a public, immutable system for finding the current state of any given did.etho document.
So how do you actually use them then? How do you interact? The spec must cover that, right? Like the basic operations.
It does. It details the standard data operations: create, read, update, and delete. CRUD.
CRUD, right, the classics.
Yeah.
Let's start with create. How do you get a did.etho DID? Do I have to go like mint or register it with this registry contract?
This is where that design choice, tying it to the Ethereum address, is actually quite elegant, quite simple.
How so?
Creation, according to the spec, is implicit.
Implicit, meaning?
Meaning you don't perform a transaction on the registry to create the DID identifier itself. If you have an Ethereum address, if you control the private key, you automatically are the subject of an ETHO D associated with that address. It just is.
Wow. Okay, that's significantly different from a lot of systems. No separate onboarding just to get the identifier.
Yeah.
It exists inherently if you have the address.
Exactly. The DID is formed mechanically by just sticking did.etho in front of your Ethereum address minus the 0x.
Simple concatenation.
Yep. Using their Alice example again.
Yeah.
If Alice has the address 0x1f4b, etc.
Right.
She automatically inherently has the DID did.etho.1f4b, etc. The creation is just a property of owning the address. It's not an action you take on the registry contract.
That is a powerful concept, linking the identifier directly to control of the blockchain address.
Okay, so creation is implicit, automatic. What about read? If I have someone's did.etho DID, how do I, look up their DID document, find out the details?
Right now, you interact with the registry smart contract. That's its job. You resolve the DID, basically look it up, by calling a specific method on that contract. It's called getDocument.
GetDocument. And the spec gives the technical details for that call. It does, yeah. It mentions the interface method signature is getDocument. And it raises a key point about trust, even on a blockchain.
Ooh.
It suggests that for maximum trustworthiness, you should probably query multiple Ethereum nodes running the registry contract and compare the results. Or even deploy your own node.
Ah, right. Just don't trust, verify. Even with smart contracts, check the source.
Exactly. It also notes there are simpler ways to resolve sometimes, like maybe just fetching the authentication property specifically, if that's all you need.
Okay, so you call getDocument, maybe check a few nodes.
Yeah.
What does the document you get back actually look like? What's in it?
The spec includes an example ETHO DID document, and it looks pretty much like a standard W3C DID doc.
Okay.
You've got your @context fields setting the stage. Crucially, the main ETH field contains the full did.etho string we've been talking about.
Makes sense.
Then there's usually a public key section or maybe a verification method now under newer specs, which is fundamental for, verification.
Right, the crypto part.
Yeah. And in the example they show, the object inside public key has its own ID, it has a controller, and it explicitly lists the Ethereum address.
Reinforcing that link.
Totally. And notice how the ID and the controller within that specific public key object, they both refer back to the main DD string. And the Ethereum address listed there, it matches the address used to form the DD in the first place.
Gotcha. So the document itself confirms the link back to the originating Ethereum address and provides the keys you need to verify signatures or whatever.
Exactly. It's the instruction manual and the keys for proving control over that DD.
Okay, that covers read. What about update? Say I'm the owner of the Ethereum address, so I'm the subject of the DD day, and I want to change something in my DD document, maybe add a new key or update a service endpoint.
Right. So to update the document, the DD subject, the owner of the address, calls specific functions on that same registry contract.
Okay, interaction with the registry again.
Yes. And the specification gives a key example. Managing delegates. Yeah, these are other DIDs or maybe even other Ethereum addresses that you authorize to perform certain actions on your behalf. The spec specifically mentions they can modify the authentication property in your DID document.
Whoa, okay. So I can basically give someone else permission to change how my identity is verified.
Pretty much, yeah. The spec gives the method signatures for it, like add controller, delegate string.
Add controller?
But the delegate parameter is the DID string of the entity you're granting this permission to. And conversely, there's remove controller delegate string to take that permission away.
Okay.
And the document notes, there are probably other update methods on the contract, but these delegate functions are the main examples they provide to show how updates work through contract calls.
Giving delegates the power to change authentication methods. That feels really significant. Does the spec say more about what that means?
It does, and it's a critical point. It explicitly states that delegates specified in the controller property have the same privileges as the DID subject themselves when it comes to changing the value of the authentication property.
So no difference in power level for that specific crucial property?
None. That's a powerful, maybe even dangerous level of delegation. Implementers have to be super careful with that. You're essentially giving someone else the keys to the kingdom in terms of how your identity is proven.
That is a massive security consideration.
Yeah.
Okay. Create, read, update, Covered. What about the last one? Delete. How do you get rid of a did.etho DID if you need to?
Right. Delete, or deactivation, as the document calls it. It involves a couple of things happening. First, you remove all the verification methods from the associated DID document.
Okay, strip out the keys.
Yeah. And second, you set a specific flag within the registry contract for that DDI. The core idea is you're leaving the BID document in a state where there's just no way left for anyone to authenticate the holder's identity using it.
Makes sense. No keys, no proof. Is there a specific function call for that?
Yep. The method signature is deactivated did and string. And the did parameter is just the full did.etho string you want to permanently deactivate.
Okay. Removing verification methods, setting a flag. It sounds pretty final. Is it final?
This is maybe the most significant design choice the spec highlights regarding deletion. It emphasizes that the deactivation of an ETHO DID is permanent.
Permanent. Like really permanent.
Yes. It cannot be registered again. It cannot be reactivated again. Once it's been deactivated via that function call, it's gone for good.
Wow. Permanent deletion of a blockchain-tied identity that's derived directly from your address. That's a major design constraint, isn't it? A really key takeaway from this spec.
Absolutely. It's a very strong, irreversible form of revocation. No takebacks.
Okay, shifting gears slightly. What does the document say about security and privacy? What should people building with this, or maybe using it, keep in mind?
It outlines several really crucial points for implementers. First, it states clearly, one Ethereum address cannot be the subject of multiple ETHO DIDs.
One address, one DID.
Right.
Got it.
Right. It's a one-to-one relationship enforced by the method itself. Second, reinforcing what we just talked about, the permanence of deletion. A deactivated ETHO DID means the corresponding Ethereum address permanently loses all capability to perform any operations on that specific DDI.
So if you deactivate it, that address can never control that specific DD again, ever. No undo button.
Correct. It's final for that identifier. Then, as we discussed, that power given to delegates.
Right, the controllers.
Yeah, the power they have over the authentication property is a huge security point.
Yeah.
That delegation needs extremely careful handling by the DID subject.
Definitely.
And finally, a really critical point for privacy, ETHO DID documents should be limited. They should only contain the technical information needed for interaction and verification, things like, keys, service endpoints.
Okay.
They should not store personal information about the DDI subject directly in the document.
That's crucial. Keep the PII out of the public DID doc. The document is about how to interact, not who the person is in detail.
Exactly. It's about mechanism, not sensitive data storage.
Does the document point to any working code examples or further reading?
It does. It mentions a reference implementation is available, usually implies code on GitHub or somewhere similar, so developers can see the spec in action.
Useful.
And it also roots itself by referencing things like the Ethereum GitHub repos and, importantly, the foundational W3C DID core specification. It shows it's not built in isolation. It's standing on the shoulders of existing standards and tech.
Okay, wow. That gives us a really clear picture drawn straight from this technical specification. We've seen did.etho is this identifier, intrinsically linked to an Ethereum address.
Starts with did.etho, lowercase.
Right. Creation is implicit, got the address, got the DID. Reading it, resolving it, involves querying that specific smart contract registry on Ethereum.
The get document call.
Updates happen by calling functions on that registry, including adding these really powerful delegates who can manage authentication methods.
Add controller, remove controller.
And deletion. Deletion is this permanent, irreversible act of deactivation via another registry call.
Deactivated bit. Final.
And we've got those key guardrails. One DID per address, the absolute finality of deactivation, the significant power of delegates, and that vital privacy directive, keep personal info out of the DID document itself.
Yeah, I mean, this spec really provides the technical framework, the rules of the road, for how entities can establish a verifiable presence on Ethereum. It leverages the address control, the smart contracts, all without needing a central company to issue the core identifier.
And understanding these mechanics, these nuts and bolts, it really matters for you, the listener, because this is the foundation layer. This is how verifiable claims and credentials can actually be built in a decentralized way.
Right.
If you have a did.etho DID tied to your address, other people or systems can issue verifiable credentials to that DID. You could potentially prove you took part in a DAO vote or received an NFT as like proof of attendance or wholesome certification,
Hmm.
all anchored to this decentralized ID you control with your Ethereum keys.
It connects your on-chain activities or even off-chain attestations back to a resolvable, verifiable identity layer that you control.
So thinking about the specifics we pulled from this document, particularly that really explicit statement about deactivation being permanent.
Yeah, that one stands out.
It cannot be registered or reactivated. And since the DID comes from the Ethereum address, and deactivation means that address permanently loses all capability to interact with that specific DID, well, what does that specific design choice really imply? Thinking about like long-term identity management, or what happens if keys are lost or compromised, or even concepts like digital legacy within this particular did.etho framework. It introduces a level of finality directly from the spec, but, well, it has some pretty profound implications to chew on, doesn't it?